All right, here we go. We've got a initially uncharged capacitor of 5 microfarads. We've got a battery of potential of 12 volts. And then we've got a resistor that has a resistance of 14 ohms. So we close the switch. The questions are the charge on the capacitor, voltage across the capacitor, and the current in the circuit immediately after the switch is closed. That's what we're finding first. So remember, when the switch is closed, initially there is no potential difference here, right? There is no potential difference because there is no charge. The charge comes when we allow the current to flow, when we allow the electrons to move through the circuit. But at this point, that ain't happening. So right at the beginning, as the switch is closed, there's no potential difference because there's no charge. However, there is going to be current flowing through the circuit. Because remember, initially, because there's no charge there, there's no potential difference there, we can basically just kind of treat it as if it was just a wire, which means that we can use our equation that the V equals IR. Yeah, I know in your formula packet it's actually I equals delta V over R, but old habits die hard. This is the one that we used a lot in university, so I'm going to go ahead and use that one. I put in my potential, which is 12 volts, because all of that potential needs to be lost in the resistor right now. I'm solving for the current. The resistance is 14 ohms, and so I simply go 12 divided by 14, and I get my current, which is the total current in the circuit, which is 0.857 amperes. And there we go. We've got the current. All right. Now, let's move on to letter B. So letter B says, what is it going to be after a long time? Now, in AP, they just want you to show understandings of the principles, okay? Is there mathematics that would allow you to find the current, the potential, the charge at any point in time between 0 and infinity? Absolutely. And if you stick with physics, if you go more into electricity, if you do any physics in university at this level, then they'll probably teach those things to you, because you can use logarithms, you can use exponentials, you can use calculus a little bit there if you want, but at this point we don't want to have to worry about that. It's all about the principles and understanding what's going on. All right, so we're always in AP going to be interested about time 0, and we're always going to be interested in time infinity, what happens after a long time. So after a long time, of course, things are going to change just a little bit, because we now are going to have the situation where the capacitor is completely charged. Now remember, when it's completely charged, no more current will flow through. So we actually already know the answer for B, that the current is going to be 0 amperes, because the capacitor is going to be fully charged. It's going to have a potential difference of 12 volts, which means there's no potential left for the resistor there. Now, of course, that answers another question, which is that it should have a potential difference of 12 volts there. Now, last of all, the question does want us to find the charge across that capacitor. So to find the charge across the capacitor, we're going to use the formula that we learned before, which is that the potential difference equals the charge over the capacitance. Now we have the potential difference there, which is 12 volts. We are looking for the charge. We have the capacitance, which is 5 microfarads. And so when we put those together, we should end up getting 60 microcoulombs for our charge there. There you go. Ta-da! Let's try something a little bit harder, eh?